we're going to continue learning more about right triangle trigonometry. Today we're going to look at how to use it to find a missing angle. So far we know that all angles in a triangle have to add to 180, but if I only know one of them, I'm not able to use the triangle sum theorem to find other ones. So we're going to use SOHCAHTOA. So in this one, we're going to find R. So R is my reference angle. Okay, so here, across from 90 is the hypotenuse. My reference angle makes 8.9 the opposite side and 3.1 the adjacent side. So in this one, my angle is my unknown. So when I pick which ratio I want to use the two sides that I know. So again, according to SOHCAHTOA, okay, O and A go with tangent. So we're going to set up that same equation. Tangent, I don't know the angle, so that's my unknown. And then tangent is always opposite over adjacent. So that's going to be 8.9 over 3.1. Okay, so now you might say, okay, we want to get R by itself. So how do I get rid of tangent? We are not dividing by tangent here. This is not multiplication. This is saying the ratio of angle R is this side over this side. So something to know is that all of our ratios have inverses. Okay, so I want you guys just let me find a good spot for this. Okay, so I'm going to say, sorry, I want to make a good spot here. Okay, I'm just going to do it. Let's do it at the bottom here. We're going to do it at the bottom. Okay, so here we have the trig function and its inverse. So just like multiplying by 2 and dividing by 2 are opposites, they're going to cancel, or square root and squaring, adding 1, subtracting 1, those are inverses. So sine inverse is what that looks like. Cosine is cosine inverse, and tangent is tangent inverse. So we will always use an inverse when finding an angle. Okay, and our reason for that is because I need to get rid of tangent to find an angle R. So it's always the trig function of the angle. So here's how I'm going to do this. So I'm going to show this in the next step. So I'm going to apply tangent inverse to both sides. Sorry, I'm running out of room. Okay, so tangent inverse of tan of R, tan inverse of 8.9, 3.1. Okay, so what I'm doing is I'm applying tangent inverse to both sides. Now it's algebra, so whatever I do to one side, I have to do the other. The reason I'm applying tangent inverse is tangent inverse and tangent cancel. They're opposites. So I'm left with R equals tangent inverse of 8.9 over 3.1. So I'm going to enter this in the calculator. So here's what I do. So above tangent, you see that tangent inverse is in blue. So to get that, we're going to hit second tan. So there I see tangent inverse, and then I'm going to enter that fraction. So 8.9 divided by 3.1. So 8.9 divided by 3.1. Now this gives us an angle. So this is an angle in degrees. Okay, so I'm going to say it's about 70.8 degrees. So R, measure of angle R, is 70.8 degrees. Okay? Now, this triangle is really hard to see, so we want to find angle G. Okay, so here is my hypotenuse. G is the opposite adjacent. So G is my unknown, so I need to know both sides. So I know the hypotenuse, I know the opposite, so O and H go with sine. So we're going to do sine of angle G is opposite over hypotenuse. So 3 root 3 over 6. I'm going to reduce this a little bit first, you guys. I can say sine of G, right? 3 6 reduced to 1/2. Okay, so now I'm going to apply sine inverse to both sides. So sine inverse of sine of G sine inverse of root 3 over 2. So sine inverse and sine cancel. So we have g equals sine inverse of root 3 over 2. Okay, calculator. So we're going to enter in second sine to get the inverse. And then I'm going to do square root of 3, okay, divided by 2 is 60 degrees. So measure of angle G equals 60 degrees. I probably didn't need that many parentheses, you guys, so let's try that. Second square root of 3. There we go. Yep, didn't need quite as many parentheses, so that's just fine. Okay. All right, now we're going to kind of recap what we learned before. So I'm going to find all missing sides. So I'm going to find AB first. So in this one, I know an angle. So according to this angle, here's my hypotenuse, opposite, and adjacent. Okay, so I am trying to find side AB. All right, so we're looking for the adjacent side and we know the hypotenuse. So this is what we did the first day with finding sides. So I know the angle, so adjacent and hypotenuse is cosine. So we're going to do cosine of our angle equals the adjacent, maybe I shouldn't do A. We'll call it AB, over 7.4. So we're going to multiply both sides by 7.4. So I have 7.4 times cosine of 32 equals AB. Okay, calculator. So we have 7.4 times cosine of 32. So AB is 6.28. Okay, BC is a side. So now I actually have some options. I can use trig again, or I could use Pythagorean theorem because we now know this is 6.28. So I could use 6.28 squared plus O squared equals 7.4 squared. Always an option. I'm going to use trig because it's faster. So I'm going to do, you can use whatever you want now. I could do tangent or I could do sine. I'm going to do sine. So I'm going to do sine of that same angle equals BC over 7.4, multiplied by 7.4. So BC equals 7.4 times sine of 32. Type that in. 7.4 times sine 32 is equal to 3.92. Now, measure of angle C. We know all three of these have to add up to 180, so I'm going to do 180 minus 32 and 90 to get angle C. So 180 minus 32 and 90. 58 degrees. Okay, this one, we're asked to solve the triangle. So YZ, I could find this doing Pythagorean theorem right now, or I could find an angle first and then do trig, okay? I'm going to do that just because I prefer it. It's a little bit faster. So I'm going to do angle Y first. So then here's my hypotenuse, opposite, adjacent. So if I do opposite and adjacent, that's going to be tangent. So I'm going to do tangent of angle Y equals 8.6 over 11. Okay, to get y by itself, we're going to take tangent inverse of both sides. Okay, so tangent and tangent inverse cancel. So I have y is equal to tangent inverse of 8.6 over 11. So second tan to get the inverse, 8.6 divided by 11. This is an angle in degrees, so it's about 38 degrees. Okay, so now to get angle Z, now that I know this is 38 degrees, I can do 180 minus 38 and 90. And I think that's going to give us 52 degrees. Okay, and now YZ, I could do trig to find. So I'm trying to find the hypotenuse. I could use either the adjacent or the opposite. I'm going to do opposite. So let's do sine of 38. Sine is opposite over hypotenuse, so 8.6 over the unknown, yz. Okay, I'm going to multiply both sides by yz. Okay, get rid of that. Now I have yz times sine of 38 equals 8.6. So now to get yz by itself, we're going to divide both sides by sine 38. Okay, so what I'm entering in here is yz is equal to 8.6 divided by sine of 38. Enter that in our calculator. So 8.6 divided by sine of 38, and I get 13.97. Okay, I think that is it for the examples. Yep. Okay, guys, so there's knowing how to find angles, but a little bit of review on how to find the sides and all missing parts as well.